Good morning. Right, we have been discussing questions in the tutorial. Yeah, today I supposed to do some questions, but people are supposed to do today only 2 hours in our class, and I'll put in near future one extra class to cover up this lacking time. Yeah, because of a reason I do only 2 hours. Yeah, people today, as the first question today, I supposed to take in your tutorial the question number 13. Question number 13. Question number 13. The first question today I supposed to take. Right. Read people question number 13 as the question today. Right, question number 13 in the tutorial, page number 3, no? Question number 13. Right. Question number 13 says something like this. The points A, B, and C have position vectors simple A, simple B, and simple C respectively referred to an origin O. Right. A, B, C have position vectors. Right. I'll take the points A, B, C like this, people. The point A, point B, point C. Point A here, point B here, point C here. Right. Referred to an origin O. That means relative to origin O. Vector origin is O. The point O can be anywhere on this white plane. Okay. So then I mark that point O like this. It is not compulsory to mark that point O, the origin, right? But I'll take it somewhere here. Okay. Now people. Right. This point O has the position vector, people null vector. We know position vector of the vector origin O is null vector. Right. Point capital A has the position vector, people, simple A. So therefore, this OA vector only, simple A. This OA vector only we call as the position vector of A. Sometimes that position vector of point capital A, we write nearby the point capital A here for our convenience. So the thing you have to get here is, people, OA vector only we define as the position vector of the point capital A and termed as simple A vector. And that of B, this way. This is a simple B vector, right? And this is simple C. Right. This is what we are given. Given that point capital X lies on AB produced, so that ABBX 2:1. Right. AB produced. Now, when we join AB, this is the line joining A and B, no, people. AB produced means, people, this way we have to extend this line AB passing the point B this way. AB produced means that. AB produced means that. Given that the point X lies on AB produced, so that ABBX 2:1. So therefore, people, somewhere here, suppose we have point X, its position vector, then we must write using the corresponding simple letter simple x. Okay. Then the ratio given is AB is 2, Bx is 1. Right, this way. Find simple x vector, the position vector of capital X in terms of A and B. Right, so then people, this is how we take that. Right, we can write the position vector of the point capital X this way. People, you know, here this AB Bx, volume is low. Right, now I can write the position vector of the point capital X this way, people. We can write this AB Bx ratio given AB Bx ratio given 2/1 this way. By this, people, we can write using the cross multiplication 2 times Bx. Now you can very clearly see here A to B, B to X. We take this AB line segment and Bx line segment, both are in the same line, A to B and B to X. The directed direction is also the same, people. So therefore, all those properties we can bring into one vector equation, right? This way, AB is equal to Bx and A to B, B to X, the line segments are parallel and also the same directed direction. So therefore, we can write this as how, people? AB vector is equal to 2 times Bx vector, right? This we can write. Now AB vector here, AB vector you can write as how, people? A O plus O B. Or else you can take this AB vector, you know, second letter position vector minus first letter position vector is the way of writing that. B vector simple B minus simple A is equal to 2 times Bx vector. We can write position vector of capital X, simple X, minus position vector of B, simple B. Okay, right. So now by these, people, we can subject this simple X. Remember, we have learned ratio theorem. We have learned ratio theorem. People, when you answer any question in vector, don't use this ratio theorem directly. Understood? The reason is, people, then you might ask, why did we then learn this ratio theorem? People, we should know there is something like that called as ratio theorem. That's why we learned. But at the examination, when we work out the question, people, don't use the ratio theorem directly. You lose mark. Okay. So therefore, hereinafter, actually, if we find the question that we can actually do by using the ratio theorem very easily, I'm not going to use that ratio theorem again, because you should familiar to get the answer without using the ratio theorem directly. Okay, because for those steps we get marks. Once you use the ratio theorem, due to the direct use of the ratio theorem, people, you lose marks, 5 or 10 marks may lose. Okay, so therefore don't use the ratio theorem directly. Right. Now here also, people, we could have used ratio theorem directly to get the position vector of the point capital X. Don't do like that. You have to do it like this. Yeah. So now what we do is, this 2 I can bring to the left hand side, denominator, and then what we have on the right hand side is x minus b brings this side, b minus c divided by 2 plus b is equal to simple x. Then we get, what is this people? This and this we can simplify. Take common denominator as 2. Then 2b plus b is 3b, no? 3b minus c divided by 2 is the simple x vector. Okay. So therefore, we can write position vector of x. It is denoted by simple x, no? Simple x is b minus a divided by 2 that we found. Okay. Next one, people, if y, point y lies on BC, point y lies on BC, right? Between B and C, so that BYYC 1:3. Here. Somewhere here we have the point y. Its position vector should be taken then as simple y vector. The ratio given here, BYYC 1:3. BY is 1, YC is 3, right? Okay. Find simple y vector, the position vector of capital Y in terms of simple B vector and simple C vector. Right, people? Now we can write that also in this manner. But people, we are given by divided by YC 1/3. Then you can use a cross multiplication like this. 3 times by equals YC. Okay. Then you know both the line segments by, YC lie on the same line, no? Therefore, by and YC are parallel line segments. Other thing is B to Y, Y to C. We move to the same direction. With the properties available in the diagram, and that one, all three, we can write as a vector equation. How, people? This implies 3 times by vector is equal to YC vector, like this. Okay, right. Now, this by vector, we can write how, people? By vector, how to write? Here, b to y vector, we can write by using the triangle law of vector addition. How? B O plus O Y. Understand? The same thing only we learned when we write a given vector using position vector of its points. How to write this one now? Position vector of second letter minus position vector of the first letter. Okay. So therefore, this is nothing but 3 times simple y minus simple b is equal to here simple c minus simple y. Okay. Now by this, people, you can take the simple y. How to take that one? First remove the bracket by multiplying 3y minus 3b is equal to c minus y. Bring this minus y to this side, that will be plus y. With this 3y together, we get 4y, people. And bring this minus 3b to right hand side, that will be plus 3b. Then 3b, and here we have c, that is nothing but plus c, no? Plus c. So therefore, vector simple y going to be 3b plus c divided by people 4. Here I'll people tell you this answer simple y, the position vector of the point capital Y, right, can easily be obtained if you use the ratio theorem very easily. See here, when I directly use the ratio theorem, here this position vector y can be obtained 1 times c plus 3 times b divided by 1 plus 3. Correct here? Look at this. 1 times c here. This is coming. Plus 3 times b. 3b, this is coming, divided by 3 plus 1, 4. We could have taken this simple y vector using the ratio theorem directly in one step, right? Then people, suppose without using this one directly, here we wrote what? This we wrote, this we wrote. Thereafter, using the properties in the diagram, all the properties available in the diagram and this relation, we could have written this one. Thereafter, writing this only, we got this answer. People, when you write like this, okay, you get 5 marks for this, and you get 5 marks for this, and thereafter subject in this way, you get 5 marks for this. So once you use, people, the ratio theorem directly, only for this you get 5 marks. Then write in this way, that 5 marks you lose. And after this one, write in this way using the position vectors, another 5 marks you get. That 5 and this 5 all to the 10 marks you lose when you directly use the ratio theorem, people, right? So therefore, when we take the answer at the examination, or hereinafter, when you work out the question, people, my advice is, don't use the ratio theorem directly. Answers are everything coming, people, but you lose marks. You lose marks. Okay. So therefore, in this way, when you work out, for this you get 5 marks, and substituting for these vectors in terms of position vectors, they are position vectors, you get marks, 5 marks, 5 marks, and simplifying and obtaining the y this way, another 5 marks. Okay. Right. Right. So now that is okay. Now what is asking next? Given that Z is the midpoint of AC, Z is the midpoint of AC, right? A and C when I join here, Z is the midpoint. Midpoint is somewhere here, no? Right here. Huh? Midpoint means 1:1. Midpoint of AC. Then ask him what, people, find, given that Z is the midpoint of AC, show that X, Y, and Z are collinear. Because collinear mean there are 3 points, no? X, Y, and Z, no? 3 points. 3 points are collinear mean the 3 points X, Y, and Z lie on a line. On a line. That means, suppose this way, we have X here, we have Y here, we have Z here. I join this X and Y and I produce that line. I join X and Y, I produce that line. On the line produced, if the point Z lies on that line, then you can see all the 3 points X, Y, Z lie on a line. Then this X, Y, Z points are called as collinear points. Collinear points. Collinear points means those points lie on a line. People, we know when we consider any 2 points, mark any 2 points on your paper page, we can draw one line passing through that 2 points. Only one line. But people, when you are given, instead of 2 points, when you are given 3 points, sometimes we can draw only one line passing through all these 3 points. Sometimes we can't. So therefore, people, if that 3 points, if we can draw a line so that 3 points come on a line, then in that case we say the points are collinear. Understand? Right. In this case also, people, we have to prove this X, Y, Z points are collinear points. That means the 3 points xy z lie on the same line. Okay. Now to show that one, we will first show people this. What? We'll first find the position vector of the point z. Right? Position vector of the point z. Z is the midpoint of AC, right? Z is the midpoint of AC. So then we can write people AZ ZC. AZ ZC. 1:1. Using cross multiplication, we get people this way. AZ is equal to ZC. AZ equal to ZC. AZ is ZC. Same line, same direction. So then you can write here what people? The vectors. This implies AZ vector is equal to ZC vector. AZ vector you can write position vector of Z, simple Z minus A, here simple C minus Z. Bring this minus Z to this side, then we get plus Z. With this Z it is 2Z. Take this right hand side, A plus C. Then Z vector is equal to A plus C vector by 2. Understand? This answer also, people, we could have obtained directly by using the ratio theorem, but we don't do like that. This way only we use. Right. So now the position vector we found. Right. Now what is asked in next one, people? Show that xy and z are collinear. The xy yz ratio also asked into calculate here. Xy yz. All right. Now up to here it's okay. Right. Now people, I am going to do next one like this. I am going to take this way. Okay. People, I am going to take first these vectors. I am going to take xz vector. I am going to take xz vector first. People, tell me how to write the xz vector. Xz vector you can write, second letter is z, no? Its position vector minus first letter position vector this way. Then substituting for this z and simple x vectors, right? By the answers we found for them, we can find xz vector, right? Now, what is simple z vector, people? It is a vector plus c vector by 2 minus simple x vector we found this way. Then you can write that one, people. How? 3b vector minus a vector divided by 2. Then we found this xz vector. The common denominator is 2. Here a vector plus c vector. Remove bracket by this minus sign. Minus 3b vector minus plus a. Okay. The once you simplify this, what do you get? We get for this xz vector something like this. This a and this a make 2a, and here plus c and minus 3b divided by 2. This is the xz vector. This is the xz vector. Right. Secondly, I am going to find people xy vector. Xy vector. I am going to find xy vector. Xy vector. I can find even how to write xy vector. Second letter position vector minus first letter position vector. Simple y vector is this 3b plus c, right? 3b plus c divided by 4 minus simple vector is that people. What? 3b minus a vector divided by 2. So once you simplify here, taking the common denominator as 4. Okay. This is 3b plus c. Here we have 2, but common denominator is 4. Then this one you have multiplied by 2. Then we get what? Minus 3b should be multiplied by another 2, no? Minus 6b. Minus minus plus. This should be multiplied by people 2. 2a coming, no? Right. So now you can simplify this. How people this way? Xy vector is equal to what? Here we have 2a and plus c. 3b minus 6b means minus 3b divided by 4. Understood, people? Right now? Yeah. Up to here, I think you can very clearly understand. Now, our purpose is to show people that x, y, z points are collinear. X, y, z points are collinear. That means all these 3 points x, y, z lie on the same line. That's what we need to prove. People, that can easily be done like this. Now I have that x, z vector and this x, y vector. Okay. Now, see what I'm going to do next. I'm going to people subject by using cross multiplication for x, y vector is equal to 2a vector plus c minus 3b vector. Okay. Also, people, we know when we use the cross multiplication by these two, we are here, we get 2 times xz is 2a plus c minus 3b by using cross multiplication. 2xz vector is equal to 2a plus c minus 3b. Understand? That way we get. So once you very carefully look at these two expressions here and here, you can see same vector expression available here and here. In other words, this and this being equal. If these two are equal, definitely this left hand side should be equal. Then we can write what, people? Therefore we can write what? 2 times xz vector is equal to 4 times xy vector. 2 and this we can cancel down like this. Xz vector is equal to 2xy vector. Okay. Right. Right. Now people see here, 2 vectors are equal. 2 vectors are equal. You know, people, when 2 vectors are equal, what are the properties? By this vector equality, you can say, people, this implies us what? First thing is this. When 2 vectors are equal, you know, the corresponding line segments are parallel. Say here, first thing is what? XZ line is parallel to XY line. XZ line is parallel to XY line. What is XZ line, people? XZ line is this here. This is the X point, no? This is the Z point. Yeah, Z point is here taken, no? Right. Shall I take that in another diagram? Here, this is the point X. Here, this is the point Y. Here, this is the point Z. All right. Now, the left-hand side line segment is XZ, this one. Right-hand side is XY, okay, this one. Right? The left-hand side line segment and the right-hand side line segment both are starting from the same point X. And those line segments are parallel. People, according to this diagram, can this XZ and XY be parallel? No, people, no. According to this diagram, can this XZ and XY be parallel? No. Two line segments are starting from a point and they must be parallel. For this diagram, people, this XZ and XY, obviously you can see not parallel, but they must be parallel according to this statement. Then people, what should be this diagram? This point Y should come onto this XZ line, or else this XZ line should go toward XY. One of that two must occur for this to occur. Suppose this point Y coming onto this, then you can see here, if this Y is coming onto this XZ line, what can you say? XZ and XY now become parallel. So therefore, definitely, in order to satisfy this condition, Y should come onto this XZ. Once after coming this Y onto this XZ line, people, what can you say? The 3 points X, Y, and Z lie on the same line. What is that? The 3 points X, Y, Z are collinear. Understand? So therefore, by this we can say XZ parallel to XY mean what, people? The 3 points X, Y, and Z must be lying on the same line. That means X, Y, Z points are collinear. Understood? People, remember, two line segments are starting from a point so that they become parallel. Two line segments are starting from a point so that they are parallel. For this to occur, people, the 3 points should be on the same line. Otherwise, this condition cannot be satisfied. Understood? Then this is sufficient, people. This is sufficient to say that what? X, Y, Z are collinear. Understand? No need to draw this way a diagram and no need to explain that in words. When two line segments are starting from a point so that they are parallel, then the 3 points must be collinear. Like that, no need to explain. It is sufficient to show XZ line segment parallel to XY mean, people. Anybody who knows maths will realize for this, the 3 points X, Y, Z should be on the same line. Understood? Therefore, you can write XZ parallel to XY means, therefore, X, Y, Z are collinear. That's enough. Collinear. That's enough, right? Okay, people, by this vector equality, what is the second property we can take? Yeah, the second property we can take by this vector equality is left-hand side length is equal to right-hand side length. But the second property, XZ is the left-hand side length, 2 times XY is the right-hand side length, people. You know when two vectors are equal, the properties by that equality we can draw. The left and right line segments are parallel. Left length and right length being equal. Second one only, people, now we are using. XZ, right, is equal to XY. All right. So once I bring this into our diagram, people, let's see what we have. XZ X, Z. Here. Okay. This relation, people, I can write another way like this. I erase this one for a while. X, Z. I bring this xy left hand side denominator like this. Now we have here 2. 2 means its denominator is 1, 2 by 1. Now I draw that diagram. X here, Z here. Right. XY. XZ is 2xy. Here we have y. All right. XY length should be multiplied by 2 to get this XZ length. Then you can very clearly see, people, this y should be the midpoint of XZ. No? Why? Here XY length, that means this, no? This length, when you multiply by 2, we get XZ, this whole length we get. Therefore, this XY length and this YZ length must be equal. In other words, y should be the midpoint. Okay, so then what is the next question asking, people? XY YZ ratio. If this and this being equal, mean, people, what? Ratio 1:1. Therefore, we can write XY YZ ratio 1:1. This way we can write. Or the same thing we can write XY is to YZ is equal to 1:1 like this. 1:1 like this, you can write it. Understood, people? This is how we complete the question. People, you can see when you go through the past paper sums, you can see there are some questions to show the points are collinear. So then when you work out those questions, people, you will come across this kind of simplification, right? Okay. That's okay, no, people? Right, that's how we do that question, right? Right. Now, as the next question, we'll take, people, question number 14. Right. Question number 14 is the next question, right? Question number 14. Take the question number 14 as the next. Take question number 14. Question number 14. Read question number 14, people. Try to understand that question. In question number 14, in the triangle OAB, OA vector is simple A, OB vector is simple B. The midpoints of OA, OB are D, E respectively. The lines BD and AE meet at G. Show that. But, people, in this case, this G is called as the centroid of the triangle. People, you know, when we consider a triangle, there are some centers. There are some centers. Till now, here, when we consider this triangle as ABC, I can mark the midpoints of these sides. This is the midpoint of the side BC. This is the midpoint of this side AC. This is the midpoint of this side AB. Suppose. Now this vertex I join to the midpoint of opposite side. This line is called as the, people, median. Median. Understood? Then what is median? Median means vertex of a triangle is joined to the midpoint of its opposite side. That's called as median. This way, people, we can draw 3 medians for a triangle. This way. Then people, when we draw this way, when we construct these three medians, whichever the nature of the triangle, that three medians meet at a point like this. That three medians meet at a point like this. This point is denoted by the letter G, and people, this G is called as the centroid. Centroid. And this G, centroid, divides each median in the ratio 2:1. Ratio 2:1. Ratio 2:1. Right? And that's what in this question, people, we are asked to prove. So this is one center. Like this, people, another few centers available for a triangle. I'll, of course, show you what are the other centers. You should know these ones. People, the other one is, you know this one already. When we consider a triangle, this we have done in your levels under constructions, under geometry. When we consider angle bisector this way, okay, this angle is bisected by this line. So therefore, this is called as angle bisector. This angle we bisect. And this angle we bisect. That angle bisector, when we draw, that bisector will pass through the point of intersection of these two bisectors. Then we get another point. That is called as, people, I. What is this I? In center. This is called as the in center. That is another center for a triangle. I. Taking this I as the center, and from here to any side of the triangle, from here to any side of the triangle, the perpendicular distance. From here, we take, there are three sides for the triangle now. From this point I, we take the perpendicular distance to any side. Taking that perpendicular distance as the radius and this I as the center, we can draw a circle. That circle will touch all these three sides internally, and the circle is going to be like this. This circle is called, people, in circle. So therefore, that is the another point called as in center. That is the centroid. Another center is there, people. It is this. Now, when we consider this way a triangle, from these vertices, we draw perpendiculars to opposite side. This way we draw perpendiculars. The other perpendicular, when we drop from the rest vertex to opposite side, that will pass through the point this. Then these three perpendiculars, they meet at a point. That point is denoted by the letter H, people. It is called as the orthocenter. Orthocenter. Another one, you know, when we consider a triangle like this, for this triangle, select the midpoint of a side. At that midpoint, draw a perpendicular to this side like this. This is called as the perpendicular bisector of the side. This is passing through the midpoint of the side, perpendicular to this side. This is therefore called as the perpendicular bisector. Like this, people, we can construct three perpendicular bisectors because there are three sides. So then we take the other one, get this way. These two are equal. The other one is this. then that people, all these three perpendicular bisectors will meet at a point. That point is called as people, it is O, denoted by O, is called as what people? Circumcenter. Circumcenter. Right? Taking this point O as the center, and from here to any vertex, from here to any vertex of the triangle as the radius, we can draw a circle. Taking this point O as the center, and from here to any vertex, we take as the radius. When we draw such a circle, people, that circle will pass through the three vertices like this. This is called as what, people? Circumcenter. This you have constructed in your order. Another one is there, people. Excenter. We have excenter. When we consider this way, the triangle, people, this side and this side we can produce this way. Then the angle bisect of this angle we construct, angle bisect of this angle we construct, they meet at a point like this. This point is called as, people, excenter. Excenter. Okay. The importance of this excenter is, when we take from here to this side the perpendicular distance as the radius, and this one as the center, when we draw a circle, that circle will touch this line, and this line like this. This way we get a circle. That is called as the X circle. It's called as the X circle. So like that, we can draw 3 X circles, because this way we can produce this side, then this side, then we can construct 3 X circles. Right. Now, the other thing is, taking a triangle, we'll take any triangle, scalene triangle. Scalene triangle means, you know what is meant by the scalene triangle. Scalene triangle. Scalene triangle means, people, the 3 sides are, people, different. Scalene triangle means 3 sides are different. Taking this way a scalene triangle, I can construct for that scalene triangle this G, this O, and this H. For the same triangle, that 3 centers, centroid G, and the circumcenter O, and this orthocenter H. All 3 centers now we can find by constructing that way. The constructions, we can locate the 3 points G, O, and H. Okay, by constructing that way median and finding the point of intersection of the medians, we can find this, people, G. And finding the perpendicular bisectors of the sides and finding the point of intersection of those, we can find O. And constructing this way from vertices to opposite side, the perpendicular side, finding the point of intersection of them, we can find H. People, these 3 points G, O, H, when we find for a given any triangle, people, these 3 points always lie in a single line. In other words, these 3 points are collinear. You know the meaning of collinear. 3 points are collinear mean, people, when we join a line by taking 2 points and producing it, the third point comes onto that line, the 3 points on the same line. That is the meaning of collinear. So therefore, this GOH, all is collinear. Okay. This one discovered by the mathematician you have heard about, Euler. Euler is the one who discovered this first. So therefore, people, this line is called as the Euler line. This line is called as the Euler line. What is this Euler line? For any triangle, we can find the position of centroid and orthocenter and the circumcenter. These three centers means 3 points, no? These 3 points lie always on a single line, whichever the triangle. So that one is called as the Euler line. People, now in the future, you will of course work with these points. What? Orthocenter, incenter, circumcenter, excenter. Right? As a pre-knowledge, I explained here itself now. Right? So now we use these centers, especially in the straight line lesson under pure mathematics. We have another separate lesson called as straight line lesson. In that straight line lesson, people, we will come across what questions regarding the centers. Okay, so therefore, it is a very important one. By watching this recording, people, in a separate paper, you have to take down this notes. I am not going to give you time at the moment. It is wasting time, right? So then one by one, you can take down. Okay, all right. Now people, this question of 14 saying, first thing is that in the question of 14 it says, we have to prove when we construct this way, the three medians, first thing we have to prove is the three medians meet at a point. Right? People, this way, median means a line, no? When some number of lines pass through a point, when some number of lines pass through a point, then those lines, we say concurrent. Concurrent means, people, those lines concurrent means what, people? All those lines pass through a point. They meet at a point. Understand? Then here the three medians show that the three medians are concurrent. Concurrent means that three medians meet at a point, or they pass through a point. Okay, so that is the first one, no? Yeah. Right, so then we'll prove this way. Okay, right. Right, now we can come to this. Well, I am going to take question of 14 is the one we are considering, but I am going to do this in common, right? In common, this way. Right. People will write the question like this. Number 14 you can do as homework. In general, I am going to prove this result. What result? The three medians concurrent for a triangle, right? I write down that question like this. Write down, show that for any triangle, the three medians are concurrent. Also show that also show that this point divides each median in the ratio 2:1. 2:1. Right. 2:1. Right. Let's see people how to do this now. I'm going to take a triangle like this. The triangle is ABC triangle. The triangle is people ABC triangle. Huh? This is ABC triangle. A here, B here, C here. Right. Now suppose somewhere on this board we have that vector origin O. Right? Related to that vector origin O, I am going to take the position vectors of the points A, B, and C as simple A, simple B, simple C. Understand? I'm not going to anyway show that vector origin O. Somewhere on the board we have the vector origin O. Related to that vector origin O, let us take the position vectors of this A, B, C points as simple A vector, simple B vector, and simple C vector. Understand? Right. So then I mark that here. A, this is B, this is C. Okay. All right. First draw the diagram, people. First draw the diagram. Right. Shall we then write few sentences? Write down like this. Let the triangle BEB, let the triangle B, capital ABC, capital ABC, relative to a vector origin O, relative to a vector origin O, relative to a vector origin O, let the position vectors of the points capital A, capital B, capital C, capital C, BEB, simple A vector, simple B vector, and simple C vector respectively. Right? Write down. Let the midpoints, let the midpoints of AB, BC, and AC let the midpoints of AB, BC, and AC BEB, capital D, comma capital E, and capital F respectively. Right. Now, people, I am going to join this CD median and this BF median. Right. People, when we consider any two non-parallel lines, you know, parallel lines never meet, no? Parallel lines never meet. Non-parallel means they are not parallel, no? When we consider any two non-parallel lines, definitely somewhere they must meet. Here also, people, this CD and BF, obviously non-parallel. Therefore, they must meet. As in the diagram, we can see the crossing point. That crossing point of the lines only be called as the meeting point, or sometimes known as the intersection, point of intersection. At that point, I am going to take as people point G. Okay, all right. I am going to take this as point G. Okay, and I am going to assume this point G divides each median this way. This side 1, this is lambda. This is 1, this is mu. First, I am going to find out this lambda and mu. Understand? Yeah. Write down that also. People, we are going to make a proof. This is not the question number 14. The question number 14 you can do after this. This is a general proof. What, people? The three medians for any triangle meet at a point, and that point divide this each median in ratio 2:1. That is the one I am going to prove in general, not the question number 14. After completing this proof, you can do the question number 14 very easily. Right. Then you can write like this. Write down like this. Construct the medians. Construct the medians CD and BF. CD and BF. CD and BF. Right. Let the point of intersection of these medians BEB, capital G. Also, let we write this way, people. CG divided by GD equals lambda and BG divided by GF equals mu. This we take. Right. Now, this is how we take this answer. People, in this case, in order to make easier this proof, I am going to use the ratio theorem, right? For this proof only, right? But we know when we work out a question at the examination, we don't use the ratio theorem. Because this ratio theorem in nowadays, when we were doing our A levels, we could have used that directly, the ratio theorem. From time to time, people, the marking schemes patterns get changed. So at the moment, once we use the ratio theorem, we lose mark. But for the proof of this, I use, otherwise our steps will be more, right? To get the answer easily, for the proof of this easily with people, I am going to use the ratio theorem. Okay, right. So people, this is how we take that. Now, this point D is the midpoint. Therefore, the ratio is 1:1. Right? I can take people position vector of point D. Position vector of point D. How to take that one, people? Since D is the midpoint, 1 into this B plus 1 into this A divided by 1 plus 1. Understand? Right? I think what is that? A plus B by 2, no? A vector plus B vector divided by 2. Okay. Then the position vector of D is A vector plus B vector by 2. Right? Okay. Now I am going to take people this AG vector. I am going to take this AG vector. Right? This AG vector I am going to take. This AG vector I am going to take. Okay. Even how to take this AG vector? AG vector I can take this way. AD plus DG. Okay. That way I can take. Right? AG vector. Secondly, people, I am going to find the same AG vector using another way. By finding the point F position vector, right? We can find this same AG vector. Now we have this AG vector in two forms. We can now equate them. Understand? Thereby, we can take this lambda and mu as 2. Understood? Okay? Right. And then, position vector of these, okay. Similarly, shall we find the position vector of this capital F? F also midpoint of this AC, no? Therefore, the ratio is 1:1. Right. Position vector of D also I am going to write here itself. Position vector of F, not D. F going to be what, people? 1 into C plus 1 into A divided by 1 plus 1. Then what is that? A plus C divided by 2, no? Right. Okay, now we'll see how to find this AG. Right. AG vector I can find like this. Now, AG vector. How to write, people, AG vector? AD plus DG. AD plus DG. AD plus DG. Okay. Then I can write AG vector. Right. How to write, people? A D vector. A to D vector, how to write? Position vector of second letter minus position vector of the first letter. No? Right. Then AD vector I can write like this. Position vector of D minus position vector of A. What is that? Position vector of D is A plus B divided by 2. That of A is minus A. Plus. Can somebody tell me how to write this DG vector? DG vector we can write like this. This DG vector we can write as a part of DC vector. What is that, people? DC vector we divide by what? 1 plus lambda. Since we need this DG vector, the corresponding ratio is 1, no? By 1 we have to multiply. Then we get DC divided by 1 plus lambda. Is this DG vector? Okay. But what is DC vector? Position vector of C minus position vector of D. Understood? Okay. So then we'll simplify that also. AG vector. Now take here common denominator as 2. Then here we get 2A, no? Then what do we get? B, here A, here minus 2A, B minus C by 2 here. Plus. What is DC vector? Position vector of C divided by minus position vector of D. 1 upon 1 plus lambda. Position vector of C, simple C, that of D, A plus B by 2. This way we get, people. Okay. Now you can write AG vector B minus A by 2. Right here, take what, people? C, DC vector C minus position vector of D, no? Right now. Then 1 over 1 plus lambda. Here take 2C minus A minus B by 2. We get like this AG vector. Right. Okay, no? Right. Now this is the number 1. Now secondly, we are supposed to take the same AG vector this way. AG vector I am going to take in the secondly like this. AF plus FG. Right. Take like this. AG vector. I am going to write AG vector in the second form like this. AG vector I am going to write AF plus FG. AF vector plus FG vector. Right? Now I'll give 2 minutes, people. Find this AF vector. Position vector of F is known. FG vector that can be found using the FB vector as a fraction. Okay? And give me this AG in the second form. Then this right hand side, then this right hand side we are going to equate, people. Right? Take that AG vector. Right. Now when we write AG vector, AF vector, position vector of F, A plus C by 2 minus A. FG vector, how to write, people? FG vector we can write if V vector we can divide by 1 plus mu. That must be multiplied by 1. Right. The G vector is therefore, take here common element as 2 minus 2a, a minus 2a minus a, c minus a by 2, 1 upon 1 plus mu. If B vector, people, what is that? Position vector of B, it's simple B minus position vector of F, it is A plus C by 2. Okay. Now, a G vector you can write C minus A by 2 plus here take 2 as a common denominator, 1 upon that 2 comes here, no, 2 times 1 plus mu, right? Also take the common denominator here 2b minus a minus c coming. This is a G vector in the second form. Now, people, AG, left hand side of 1 and right hand side of 2 will be equal, no? Right, 1 equals 2. AG, left hand side being same, then the right hand side must be same. Now, equate the left and right. Right, equate the left and right. Equate left and right, people, what we next do is, we equate the coefficients of A, B, and C. Understand? Right. Okay. Equate 1 and 2. And now, people, you can take next one. Equate here. B vector minus A vector divided by 2 plus here. This 2 I can take before. 1 upon 2 times 1 plus lambda. And here it's now within bracket 2c minus a minus b is equal to this, c minus a by 2 plus 1 upon 2 times 1 plus mu 2b minus a minus c. Right. Now, people, what we do is we equate the coefficients of simple A vector, simple B vector, simple C vector on both sides. Right. Very carefully equate the coefficients of simple A, simple B, simple C vectors. Simple A vector coefficients, right? Here what is simple A? Minus A divided by 2. Minus simple A divided by 2 means what, people? Minus half. You know, then the coefficient of A is what? Minus half. Minus half from here. Here, people, by this thing, we have to multiply this minus A, no? Then what is the coefficient of A? This minus comes with this. Then minus this part, 1 upon 2 times 1 plus lambda. Left hand side simple A coefficient are those. Right. Now that should be equal to right hand side simple A coefficient. Here, what do you get? People, what do you get here? Minus half, no? And here, this and this we have to multiply. Minus this upon this we get. Minus 1 upon 2 times 1 plus mu. We get like that. Then once you bring this minus half to right hand side, that will be plus half, no? Then here we have minus half. When you bring this to right hand side, that plus half. Minus half plus half will cancel off. Then cancellation can be done here itself. Right? Now what we have is this minus 1 upon 2 times 1 plus lambda. Here minus 1 upon 2 times 1 plus mu we get. Right? Yeah. Now this minus and this minus you can cancel down. This 2 and this 2 you can cancel down. What do we have then, people? 1 upon 1 plus lambda is equal to 1 upon 1 plus mu. Now take reciprocal of this. Take in reciprocal. Reciprocal. What do you get? 1 plus lambda. Take this other way around. 1 plus mu. 1 and this 1 we can cancel down. That gives lambda equals mu. That's a good result to us. That we obtain by equating coefficients of A on both sides. Now we equate the coefficients of B on both sides. Another equation we can do. By using them, you can find this lambda and mu. Okay, this lambda and mu. Right. Equate the coefficients of B on both sides. Coefficients of B. Here people what? We get half, no? Here half, no? And here minus this part. Minus 1 upon this. 2 times 1 plus lambda. In the left hand side. What is that on the right hand side? We have to multiply this 2 and this to get the coefficient of B. Then what happens? What happens to there? This 2 and this 2 will cancel off. Only 1 upon 1 plus mu we get as the coefficient of B on the right hand side. Okay, this will we get, people. Now we can use this relation lambda equals mu, no? Right. Now we can simplify that. Then this is what I do. I keep this half here, bring this to right hand side. 1 upon 1 plus mu. Bring this right hand side, this minus will be plus. 1 upon 2 times 1 plus lambda. Okay, people. But what is lambda equals mu, no? So therefore, I can put for this lambda the value mu. Half 1 upon 1 plus mu plus 1 upon 2 times 1 plus lambda is mu. Here also we have 1 plus mu. Then we'll take the common denominator on the right hand side as 2 times 1 plus mu. Then this should be 2, no? 2 plus 1. Why? Our common denominator is 2 times 1 plus mu. Therefore, this should be multiplied by 2. Then people, you can cancel down this and this. Use the cross multiplication to this end. 1 plus mu is equal to 2 plus 1 is 3. Bring this 1 to right hand side. Mu is 3 minus 1. Mu is 2. Mu is 2. When mu is 2, people, mu and lambda being equal, no? Therefore, lambda also 2. Therefore, lambda is also 2. Now, we got the first answer. What is that, people? This point G divides this median BF and this median CD in the ratio 2 is to 1. Mu is 2, no? 2 is to 1. That part is okay. Right, people? Now, another one more thing is there. What is that? Our question was what? When we construct these 3 medians, first thing we have to show is these 3 medians meet at a point. Secondly, that point divides each median in the ratio 2:1. Right. So therefore, another little part available to prove there. Yeah. Okay. Right. Then people, this is what I do next. This is how I do next. Right. Now I am going to find this position vector of G. Position vector of G I am going to find. Okay. Right. That could be found very easily this way. Position vector of G I am going to find. Right. Even AG vector is this, no? This is AG vector. Right now. It contains mu. The value of mu now we know. Okay. Right. We can write like this: AG vector. AG vector, right? We equated this to, no? Then this is AG, that also AG, right? C minus A divided by 2 plus 1 upon mu is 2, no? 2 plus 1 is 3. 3 into 2 is 6. 1 upon 6. And here 2b minus A minus C, right? Even how to write AG vector? Position vector of G minus position vector of A. I am going to assume the position vector of G as simple G vector. Understood? Right. So this is G minus simple A. I am going to assume the position vector of G as simple G vector. Right? Yeah. Okay. Then we'll take like this. C minus A by 2 plus this one. Simplify this, people. 2b minus A minus C by 6. Bring this A to right hand side and simplify this. G vector is now C minus A divided by 2 plus 2b minus A minus C by 6 plus 8. Take common denominator and people simplify that. Take common denominator as 6 people there and simplify this. Position vector of G, therefore this multiplied by 3, no? 3C minus 3A. Right. This one change, 2b minus A minus C, no? 2b minus A minus C plus 6A. Now simplify this, people. G. What is that? Here 6A minus A minus 3A, then 2A. 2b. 3C minus C is 2C divided by 6. Cancel down this 2. Take this 2 out and cancel down with this 6. 2, 2, 2. We can cancel down with this 6. We get 3. Then position vector of G is what? A plus B plus C divided by 3. Now up to here, correct. Okay, position vector of G we found. Now another thing is there. What is that? We drew the triangle and constructed 2 medians. Those 2 medians are CD and this BF. they of course intersected at G. And now we have already found the ratio, this G divides each median. What are the ratio? Lambda 2, no? 2 is to 1, 2 is to 1. Another one more thing we have to find. What is that, people? When we draw the next median, that is the median joining this A and E. E is the midpoint, no? Of this side, we see. When we join this A and E, AE line, we have to prove that AE line definitely passing through the point G. Then only the three medians will be concurrent. First part of the proof will be completed. Not only that, that median AE also, we have to prove this G divides in the ratio 2 is to 1. Therefore, another two parts we have to prove. What is the first part? AE median, when we draw AE median, we have to prove that AE median passing through the point G. First thing is that. Secondly, that AE median also, the point G divides in the ratio of what? 2 is to 1. Now, once we do that, prove only, people, the whole proof will be completed. Right, now this is how I do that, people. Now, this position vector of G, A plus B plus C divided by 3 is very important to prove that. Okay, then we can come to that. Right. Position vector of G, I need a position vector of G. It is simple. G vector is equal to A plus B plus C by 3. Right. Okay. This is okay. Now this is how I do this, people. Right. Now I construct this way, people. I take somewhere here the point E, and I join this A and E. Then obviously you know that AE line, according to my diagram, E is the midpoint of this BC. Therefore, AE is the third median of the same triangle. Right? Now I have drawn that third median is not passing through the point G. But I have to prove this AE line should pass through the point G. This is what I do, people, there to prove this one. Okay? On this AE median, and this is A, this is E. Okay. What is the position vector of E, people? Since it is the midpoint of this BC line, position of vector of midpoint, you know how to take. Add in the position vectors at the ending points and divide by 2, no? Right. B plus C by 2. It is the position vector of E. B plus C by 2. Position vector of A, we know, people, it's simple A. Now very carefully listen to me. This is how we prove that this AE median passes through the point G. I take something like this. People, on this line AE, I am going to take a point called as G dash. Called as G dash. That G dash divides this AE line in the ratio 2 is to 1. Can we find that point? Yeah, people. In any line, on the line we can find the point. By that point, the whole line is divided in the ratio 2 is to 1, no? Such point we can find, no? Okay, take any line you like. You can mark on that line a point that divides the whole line in the ratio 2:1. Such point available for any line. Here also, on this line AE also, we can mark a point that divides the line in the ratio 2:1. That point I have taken here as G dash. Now what I am going to do is, people, I am going to find by using the ratio theorem the position vector of G dash. Understand? Right. First draw this one, people. First this we have to draw, and then we'll write one sentence. Right. Write down ideas. Consider the median AE, capital AE. Let G dash be, let G dash be the point on this line such that AG dash divided by G dash E equals 2/1. Okay. Right now. Right, and then the position vector of G dash I can mark simple G dash, underline that. How to write that, people? By using the ratio theorem. 2 times this side position vector plus 1 times this side position vector divided by sum of the ratio figures 2 plus 1. No? 2 times this side position vector plus 1 times this side position vector. 1 times A is A, divided by sum of the ratios 2 plus 1 is 3. This and this you can cancel down. What we get, people, here? A plus B plus C divided by 3. Right. This is the result we expected. G dash A plus B plus C by 3. People. What do you understand by this result? People, what is this? Really, this, no? A plus B plus C divided by 3 means this, no? What is this? This is the position vector of the point G. The same thing here we have. Therefore, people, this point G dash should be really that G. Why? Position vector of G and position vector of G dash being the same. A point has only one position vector. That position vector and this position vector being the same. So therefore, this point G dash is no longer a different point, that G dash is G. Then what do you understand by that, people? On the line AE, what is AE, people? Median, the third median. On the line AE, G lies. What G? This G. That means, people, on the line AE is this. On this line, point G lies. That means, people, really this AE should pass to the point G, no? Otherwise, this G can't be on the line AE. That says what? Third median also passing through at the point G. Not only that, this G dash is now G, no? This AE is the third median, no? Now, third median is also divided by G in the ratio what? 2:1. Correct, no, the proof? Is it clear, people? That is how, people, we complete the proof. Okay, no? Any question? Then we can write after this. Right. Write down. By this result, we can say the point G dash is the point capital G. Is the point capital G. The point G dash is the point capital G. That is point capital G lies on the median AE, lies on the median AE. And it divides this median in the ratio 2:1. 2:1. 2:1. Then, people, what is the final result? Yeah, this third median AE also passing through the point G. That means what? This median, they meet at G. Through that point, this third median also passing. That means what? All three medians pass through a point. That point is G. And not only that, earlier we said this lambda, mu, each 2. And this time we say this G is this G dash. That G dash divide this median in the ratio 2:1. So therefore, now it verifies what? All three medians meet at the point, and that point divides each median in the ratio what? 2:1. Understood? Now that's the end of the proof. Now we'll write the last sentence. Write down, people. Therefore, for any triangle, the three medians meet at a point. The three medians meet at a point. And this point divides each median in the ratio 2:1. 2:1. That is how people we prove. Now we have question number 14 as homework you can do. Question number 14 you can do as homework. Right. Right. People, now as I told you at the beginning of the class today, I confined my class to 2 hours. Right. Now I must put an extra class. I suppose to put an extra class in the morning session, not this week, people. Most of the time next week, Thursday morning, I suppose to put an extra class. Right. Only for today, people will come to the end of the lesson because I am not having a good health nowadays. Right. Rather than cutting the class at least between 2 hours, it's a good thing. That's why today I did the class. People then we come to the end of the class today, and most probably not the this week Thursday, next week Thursday. After doing the class next Monday, I'll put an extra class. And on the other hand, people, this month, November month, we have 5 Mondays. Though we cut 1 class, never mind. But I did that class today, only 2 hours, right? So now, before going to next questions in the tutorial, people, better to do some questions. Last day I told you that up to 47, we can do questions. Then I do some more sums from this and come to the next theories. Some more theories available regarding dot product and cross product. So therefore, this lesson, people, we have to do deeply because this lesson will be coming in most of the applied math lessons. Okay. Most of the applied math lesson can be given by mixing up with this vector lesson. If you haven't learned this vector lesson properly, people, those questions come in involved in what this vector lesson you can't manage well. So therefore, don't be hurried. Don't be hurried. We will learn this leisurely, including all the things we have to do this. Otherwise, people, by covering the lessons, finally you will have covered the syllabus more early, but nothing can be done. That kind of students, of course, I never expect from my classes. So therefore, don't be hurried. You have enough knowledge to work out the questions up to 47. Try to do them. Some more difficult, not difficult, complicated questions available. Anyway, people try to take the answer. You have enough information in your mind now. Okay, so that is up to you. Okay, next week I do some questions, and after next week we come to now new theories, and thereafter we come to what questions of the new theories, and finally we come to the past paper sums questions. Okay, this takes people another little time to cover up. Okay, all right. So then today then I come to the end of the class, and next Monday we meet. And people, I think your schools will start in very near future, and some schools already started. In that case, we can't continue this class on Monday morning. In this proper online class, we continue till your annual examination in 2023. So then we have to shift this class to evening session. At the moment, people, I have a leisure time Thursday evening. Don't put any class on Thursday evening. At Thursday evening, like 8 up to 11 or 12, I supposed to continue the class. Okay. And meantime, most of the time, people, next month beginning, we start in Kandy and Kurunagala physical classes in Kandy IMS and Kurunagala Shipping Institute. We start the physical classes. It is not compulsory for all of you. Those who are willing to continue this online class, people, they can continue this online class throughout your AL until your examination. I keep this class. Okay. And those who willing to join the physical classes, they can join. But till I inform properly you, don't stop this class, right? Because sometimes I won't be able to start the physical classes at the beginning of next month, right? Due to a particular reason. So till I inform you properly, don't stop this class, because once you miss something, you can't again catch this one. Anyway, people, if you need the recording, you know how to get the recording. I'll deliver you the recording and go to that. Only for today, people, I'll stop here. Okay, right. Some students ask some questions to do in the tutorial. Can you this question, in the tutorial? Anyway, people, I know at the beginning of this lesson, you have more doubts, more questions available that give you a doubtful nature. Anyway, those questions before ending this lesson I discussed. Till then, people, all the questions that you can do in the tutorial, do. That's the important thing. This lesson is very important. This importance of this lesson you can get know by your sister, brother who are going to sit this time examination. Okay. So therefore, this lesson maybe coming with some other more lessons in applied maths. So very important lesson. So therefore, very carefully we learn this lesson without doing on the surface of lesson here and there, like most of the other classes do. Okay. Yeah, people, then we come to the end of today's lesson and we meet next Monday. Right? So nice day to everybody. We meet next day.